Hey, heavy stuff. Right, who's going to fire away? Have we all got anybody got questions, comments? Let's start off like that. Okay, Pierre, can I ask you a question?
Sure.
Pierre, have quarks ever been detected in any way or only indirectly? Or can they not be detected? Or are they just too small?
Never been detected because you don't get alone a single quark in nature.
Okay, so it is in fact in just a theory. There's no proof you can't detect it.
Uh,
It's a theory that works,
yes,
maybe, but
that's true, but the theory is consistent with everything that you can measure
uh,
in nuclear reactions.
okay. All
I
right.
think this is a very detailed explanation of the standard model of particle physics, and I still think that Brian Cox um, is it Brian Cox? No, there's another guy. Gave in one lecture a whole description of the standard model of particle physics. This is just in more details, but it's the same story.
All right.
Ask you.
Can we follow up with another question? Are there any indications of any major or even minor changes in the standard theory, new ideas, new findings that you're aware of or not? Or has it
Not at
been
all.
static for years now?
Yeah, and I think the major problem is to combine gravity with quantum mechanics. I mean, that's been a holy grail for many years. And I am not sure that they are, that they can be described by a simple theory. So the moment you go shorter than the Planck length, uh, standard physics breaks down. And that's where you would find the quantum theory of gravity. So I'm not sure that the unified grand unified theory, or one single complete theory, including quantum mechanics and gravity, will ever be found. But that's just me.
Seem to remember reading somewhere that the Planck length is not the shortest distance that can exist in the universe. It is just the limit of distance which can ever be measured or something like that. But
That's
it is
true.
possible that there can be something smaller than the Planck length.
There is something smaller than the Planck length. But I think the simplest definition of the Planck length is when gravity equals the force of gravity equals the electromagnetic force. So
Okay.
there you've got all four of them acting equally strongly. So we cannot measure beyond that. The normal laws of physics break down entirely, almost like in the singularity of a black hole.
Have you seen the Nobel Prize for Physics 2025?
No,
Something about macroscopic mechanical tunneling or something of electrons. I don't know.
no, I beg ignorance.
Okay. Are we going? Anybody else? Was it a little bit too complex?
Yes, hi, it's David Clapran. I was wondering what has this got to do with the mammoth question in the beginning? Yeah, I think I missed that point.
So yeah, they
Something
were
else.
using that as an example of carbon 14 decay, and then from that they were sort of segueing into various subatomic processes and so on.
Yeah. Then a question from last meeting we had. He was carbon dating tree rings. Now I was wondering, can you apply the same principle to petrified trees?
Only if you can find carbon there, but I think petrified trees, it's like sort of silica and minerals have sort of soaked into it, and I think don't know if there's any carbon left in it. I think it's all just minerals, so you need to have the carbon.
Yeah, but you can still determine weather patterns, though.
Yeah, no, you need to be able to do the carbon dating, I think, on that.
Yeah. And then just another comment, I was just wondering, not too complimentary to those that pursue politics and all these gamma ray, what do we call this field of study? Because most of the pictures, they're not the diagrams, they're all, what, computer generated or whatever. And then when did the electron microscope come in, and how helpful has that been in atomic research?
I think it's quite a few decades ago. Pierre, how old is the electron microscope?
I'm not quite sure, but at least 50 years.
Yeah.
In my student years, electron microscopes were there. They would have preferred to solid state physics to measure the lattice structure of polymers, etc., etc. So they've been around for a long, long time.
And then the smallest object that can be imaged, whether it's electron microscope or something more advanced, I think they can't go smaller than an atom, can they? I think they have. I've seen some stuff on images of atoms, but I think that's the smallest you can go.
I'm not sure you can go that small. That's very, very small.
Yeah, I can't remember how they do it, but I seem to be, I've seeing various articles on it. Where they found to image atoms. I'm not sure how it was done.
I think it's to do with the wavelengths or the
yeah, it might be an indirect method. Yeah.
Yeah. Now, how if light is a wave theory, does frequency and amplitude have, what effect does amplitude have on the wave theory of light?
Well, there are three parameters that are linearly, I think, interrelated. It's frequency, wavelength, and energy. Pierre, would you like to elaborate?
Yes, I think electromagnetic waves have got frequency and wavelengths. And I think the concept of amplitude would be interpreted as the number of photons. In other words, the higher the amplitude, the more photons are impinging on a certain surface. But an individual photon has only got frequency and wavelengths. Well, frequency and wavelengths are, of course, linked, determined from
the energy, frequency, and wavelength are they linked onto. So a higher frequency will have a higher energy.
That's
and a
right.
shorter wavelength.
But I think David asked about amplitude, and my interpretation of amplitude, it's got nothing to do with the individual photons.
Yeah.
It's got to do with the number of photons that are impinging on an object. That's my interpretation in any case.
And then another thing is, I was listening to the RSG, the program last Sunday. They were talking about not batteries not operating on the far side of the moon because the temperatures, you've got to keep the battery warm to generate any power. But now, what is radiation? Can radiation not be harnessed as an energy form, or is it just purely destructive?
Nuclear. Yeah, it can. And I think it is being, they actually have some satellites which are nuclear powered. Or some, I think there was wasn't there a thing that went to Mars that was nuclear powered?
I think Voyager 1 and 2 are.
Yes, they are.
When you want to go very far, you go nuclear.
So you still need something to react on. You can't pick radiation up and use it like solar. You need something to break down to change into energy.
Yes.
The energy you want.
You need that nuclear decay.
Yeah. Okay.
Well, they say they're putting the final steps on the ITER, the International Thermo, the fusion thing in France.
Yeah.
I reckon it's not so far away now. So then we could be looking at fusion energy.
Yeah, but I think the problem was that the space temperature is too cold for any chemical reactions to take place or something. So I was thinking radiation is freely available, even more outside of our little envelope. Yeah, I don't hear too much about radioactive energy being a positive force or useful force.
Yeah, perhaps batteries, but of course solar panels work anywhere in space.
There was David, I heard the same thing for the first time on Sunday night at RSG Sterre en Planete.
Yeah.
It's one of the disadvantages of putting a space station on the far side of the moon, depending on where it could be in darkness for up to 2 weeks. So then that's when he said batteries actually won't work because it'll get too cold. And then the first thing the battery power must be used for is to keep it warm enough to be able to work. I didn't think of that or know about it before Sunday night.
Yeah.
Interesting. Makes sense.
But radiation is not temperature. It's not influenced by temperature, though. So, yeah.
Yeah, nuclear radiation doesn't stop. I should imagine. Yeah, I mean, I don't know. Does it slow down if it's in those very cold temperatures, Pierre?
Not at all. It's
Not at all.
The half-life of every known radioactive isotope is known. So independent of whatever, it's an inherent property of it.
Mm.
Yeah. And,
so they could use nuclear power on the far side of the moon.
Yes, that's what Jim Adams was basically saying. They will go nuclear.
Is that who was talking? Is he one of the SKA people? Where is he from again?
No, he was the deputy director of technology development, I think, at NASA when he retired.
Oh, okay.
But he worked very closely with the Mars programs with Japie van Zyl and all the various programs. So he's very knowledgeable.
Mm.
And he talks every first Sunday night, especially because his Afrikaans is non-existent. So
all right.
Yeah, I was wondering how many results like the politicians or the physicists get for the bang for their buck. How much bang for your buck do you get from physicists and politicians? And yeah, well, when they don't come up with answers. So, yeah, good. Thanks very much. That was totally boring. I hardly understood a word they were saying, but I know it's out there somewhere. So thanks very much. Yeah. Yeah.
Yeah, thanks, Derek. Interesting.
All right. Thanks for all your attendance. If there's no more comments, can we wrap it up?
Yeah. Okay. Yeah. Go.
All right, good night, everyone.
Good night, everyone. Thanks for all the comments and info there. Yeah. Cheers. Bye.
Yeah, good night.